Today I'm going to talk about the microfiber pollution from laundering. My name is Kirsi Laitala, and I am a senior researcher at the Consumption Research Norway, which is part of the Oslo Metropolitan University. And my background is in textile engineering, and I have a PhD in product design, and I work with consumer research. So I'm going to talk a lot from the consumer and textile perspective here. So I'm going to first introduce the topic. What are these microplastics and fibers? How do they spread? What are the problems? What can we do to reduce them? How do the EU policies tackle this problem? And what could be a way forward? So microplastics are basically the small plastics that are below the size of 5 millimeters. They can be either primary microplastics that are in this small size when they're released into the nature, or they can be secondary microplastics that result from degradation and fragmentation processes in the nature. Synthetic textile fibers from laundering are considered as primary microplastics. And microfibers are one form of microplastics. Because they are shaped as as a fiber, while there are other examples like different flakes and micropads that have been used, for example, in cosmetic products. And microfibers, they can be either synthetic plastics, as Katja already presented, or they can be natural materials like cotton that are biodegradable in nature. And here I'm only basically talking about the synthetic microfibers and microplastics. And nanoplastics are even smaller than the microplastics. You basically need a microscope to be able to see them, so they behave a little bit differently when they are in contact with ecological systems than the microplastics. So here is a flow chart that shows the various ways that microfibers can enter different ecosystems, either in a marine, freshwater, or terrestrial environments. And the spread starts already at the textile production, where the fibers can end up in the air or in the waterways, as well as in the textile workers that are working in the production sites. And then when we have the garments or other textiles at home, they can release these primary microfibers while we wear them to the air, and can be seen, for example, as dust in the households. But they also are released when we launder or tumble dry our garments. And the textiles may be reused and sometimes even recycled, but they will eventually be thrown out. And unless they are burned, they will end up either at the landfills or in nature, where they after some time will start to degrade into smaller particles and then become secondary microplastics, which are a problem in, for example, when we export a lot of our clothes in Africa or other countries where they do not have the proper handling facilities for this kind of waste. And then go back to the laundering. The washing discharge water from laundering in most cases go through the wastewater treatment plants that capture somewhere between 60 and 99% of the microfibers, depending on which kind of technologies they are using and the local infrastructure. But they still will end up in nature depending on what is done on the sludge that is collected, because it's often used as a fertilizer in agriculture and then it ends up in soil. And there are very few countries that burn the sludge residual. I think Netherlands in Europe is one of the exemptions that actually do this. So also the remaining part of microplastics that are not captured by these treatment plants will end up in different water systems and cause these problems in the ecosystem health and toxicity. And Katja already mentioned some of these problems. In addition to the issues with antimony and other chemicals, the use of non-renewable and non-biodegradable materials is a problem. To say something about the magnitude, the washing of synthetic clothing, it generates up to 46,000 tons of microfibers in laundering. which equals to about 600 quadrillion individual fibers yearly in Europe. And these are really big numbers. And these microplastics have been found everywhere in blood of people and in breast milk, everywhere in nature, on top of Mount Everest and in the deeps of the Mariana Trench, as well as in the air we breathe. So some of the risks for impacts on ecological systems, there are three main mechanisms that can contribute the way that the microplastics impact the ecological systems. They're either physical, chemical, or biological mechanisms that can act individually, but also have combined effects. And currently, we don't know so much about all these aspects yet. I think most research so far is found on the physical mechanisms and especially in aquatic environments. And the main problem is the main physical problem is microplastics that the small organisms eat instead of food and get a false satiation and blockages, which can have negative effects on the growth and reproduction, even survival. And these effects are stronger for smaller organisms than that are low in the food chains, and they therefore will impact higher up in the food chain in different ways. And microfibers are especially problematic because of their shape. They are easy to be eaten, but they are also more prone to get entangled in the gut because of their shape. Because on a regular shaped microplastics are easier to get out of the body and these fibers. And the smaller size nanoparticles, they appear to be even more readily absorbed in the tissue and retain and accumulate in vital organs. And when it comes to plastics in soil, not so much is known, but they may alter the microbial activity, bulk density and carbon content, and potentially the plant growth. And when it comes to these chemical mechanisms, microfibers have a very high surface to volume ratio that increases the capacity to absorb different range of chemicals, such as pollutants. Because then when the microplastics are absorbed in the bodies, it raises the risk to having more toxic compounds in different organisms. And these potential mechanisms include leaching of plastic additives, such as the antioxidants, dyes, or fire retardants, as Katja already mentioned, and other pollutants that are in the aquatic environments. And the effect depends on the amount and nature of these pollutants and the extent of how much is bioaccumulated, how much of these chemicals are released, and what kind of health effects the specific type of species are likely to suffer. Then we also have the biological mechanisms, which are related to transfer of pathogens. For example, that the surface of microplastics provide a habitat for different organisms and microbial colonization. And one example of problems it can cause that microfibers that are passing through wastewater treatment plants may become enriched with these pathogens and then disperse these microbes further in the freshwater systems and in soils. We do not know so much about the impact on human health yet, but they are similar to ecological impacts. There's evidence for the physical, chemical, and biological mechanisms as well, acting either individually or in combination. And we basically eat, drink, and breathe microplastics, and they are found in our lungs and bloodstreams and tissues. Microfibers have chemical additives from the production, but they also start from the environment, including toxic, but also carcinogenic and mutagenic chemicals. And there is this risk of transfer of pathogens through biological mechanisms, as I just mentioned, that can increase the risk of infection. And the smallest particles, like the nanoplastics, are the ones that can pass the gut barrier and reach the bloodstream. But so far as we know, the most microfibers that we ingest are most likely to pass harmlessly out of the body. But most of the research still concludes that there are too many knowledge gaps to securely assess the health risk of microplastics in detail. And of course, it's really difficult to research this because there are ethical concerns. You can't force people to eat a lot of microplastics to find out or how dangerous they are. And it's also difficult to have a control group that has not been exposed to microfibers because basically we all have been that. So most research is based on impacts on animals, and it's assumed that human exposure to microplastics could lead to oxidative stress, DNA damage, and inflammation, among other health problems. It seems that these low levels of exposure are not likely to cause serious toxicity, but the chronic exposure is anticipated to be greater concern because these effects accumulate. And one example where we can see it is, of course, the textile workers, where the occupational health problems include symptoms like coughing, breathlessness, reduced lung capacity, and increased mucus production, and even potential to develop occupational asthma and lung inflammation. So what can we do to reduce the spread of microplastics in laundering? There's basically three different things. We can select different textiles, we can use our washing machines differently, and we can change our washing practices. And when it comes to the textile, the fiber type is very important. Firstly, if it's synthetic, and then how strong and how long the fibers are, because the shorter the fibers are, the more likely shedding is to occur. But even filament, yarn, and fabric shed when they are abraded, for example, when they are worn, and fabrics rub against each other when they are washed. And some studies even indicate that recycled polyester fabric sheds more fibers than virgin polyester. Then the tightness of the yarns and fabrics is important, as the looser materials are able to lose more fibers. And the finishing of textiles impact, if there's, for example, a coated fabric, then it's the fibers are more glued in place and do not shred as much. And then the general quality of the product, as well as the age and condition. Some studies indicate that new materials lose more than the first wash, and then reduce the shredding until the material becomes more worn and fibers start to break again, and the shedding increases as the material is aging older. And then we have these different types of washing machines and programs. What is known is that especially the top-loading machines with activator are a bit rougher on textiles, so they're more likely to increase the shedding of microfibers. And the textiles lose more fibers in laundering if they have space to move. So the machine capacity and load ratio and how much water we have are going to impact this. And the water discharge filtering system is, of course, important. So it's something that can be added to the machine in addition to the existing filters. And our own practices are, of course, important. How often we choose to wash our things instead of, for example, only cleaning stains would be a better alternative in many cases. Then we can select different type of washing cycles, temperature, and detergents. And in general, the aspects that improve the cleaning efficiency are also more likely to increase the shedding of fibers, which is a bit of problem, because we, of course, want our clothes to get clean to be able to use them for a longer time. Fabric softeners are known to reduce a little bit of the shedding, but it's not a good solution as they have environmental impacts of their own, and they can even increase the need for laundering. And in addition to laundering, also the tumble drying is important aspect, because a lot of fibers are lost in tumbling, and many of them are collected in a loft filter, while some of them are flying around in the air and end up in the dust in a bathroom. And the fibers from filters should be disposed in a way that they do not end up in nature. And it's possible to use additional filtering systems. So I will show some alternatives that are available today in the market. And basically 3 different types. You can use filtering laundry bags that are so tight that the microfibers do not pass through them. There's various types of laundry balls that catch a small part of the fibers that are floating in the water. And then there is many different versions of machine filters for the discharge water. And all of these are prone to have at least some effect, but it's really important to use them correctly, because otherwise the fibers will end up in different wrong places anyway. And as we can see, all of these are made of plastics, which is not really a optimal solution for reducing plastic pollution. So shortly about the EU strategy for sustainable and circular textiles. It has a section about how to tackle the microplastic pollution. Currently, there is no single European law that covers microplastics in a comprehensive manner. And we don't even have a method for it yet in place. The standardization work is going on to how to measure these, but it is not. They have not finished their work yet. The EU strategy for sustainable and circular textiles, it's going to includes the plans for prevention and reduction, and plan to use the eco-design requirements within the sustainable product regulation, as well as the forthcoming Commission microplastic initiative for this. And so far it states that the planned measures will target the product design, manufacturing processes, pre-washing at industrial manufacturing plants, labeling, and the promotion of innovative materials. But it doesn't really directly say that they will aim to reduce the use of these synthetic materials, which is really a pity. And they also mention options like increasing the use of these washing machine filters, development of milder detergents, caretaking and washing guidelines, end-of-life textile waste treatment, and the regulations for improved wastewater and sewage sludge treatment. So to conclude, there is potentially a large and a growing risk of ecological and human health problems associated with microplastics. And as far as you can see, the most important measure to reduce the microplastic pollution is to reduce the use of synthetic materials. Mitigation strategies should focus on the sources, because removing fibers after the end of the age is difficult or even impossible, for example, when they're in the soil. And the potential impact of other measures is too small compared to the continually increasing use of synthetic fibers, as Katja already showed us. The washing machine filters can reduce some of the fiber strength during laundering, but have their own additional impacts and will not affect the setting during the use that end up in the house dust and in the air. And it's also going to take a long time before these solutions are going to be in widespread use. And in addition to the fibers that are lost during use, the remainder of synthetic textile will also degrade into microplastic in the end, even after recycling, unless it's incinerated. So we have this problem anyway at the end. So that was my presentation. Thank you, everybody. I think the questions will be at the end.